Hi, my name is Woody Walton, and I'm a Senior Principal Solutions Architect here at Elastic. Today, I want to give a quick overview of why I believe LLMs and vector databases and vector search and retrieval augmented generation, all the above, still need a search engine to perform to their optimal accuracy and efficiency. There's no doubt that vectors are a powerful new tool in the information retrieval arsenal, but they aren't automatically a fix-all cure. The results that a vector database provides are still predictions that are based on the most likely context of those query terms and concepts within the vector space that that model understands. Let's take a simple example of a sentence that could be interpreted in multiple different ways. The teacher talked to the student because she was upset. Now, was the teacher upset or was the student upset? Without any additional context, either of those interpretations could be correct. For a lexical search engine that bases its relevance computations on term frequencies and co-occurrence statistics, developing a conceptual relevance would be exceedingly difficult. A keyword engine is restricted to finding some variant of the query terms in the document or the metadata tags in order for it to qualify as a hit. With the advent of large language models, we're no longer forced to match the keywords exactly. LLMs are trained on a large amount of content, so they understand the patterns of language usage. So a semantic search no longer has to rely on exact terms appearing in a document for it to be returned. For a vector search, much more flexible than a keyword search engine, but it still cannot determine who was upset in this phrase. The best a vector search engine can do is predict based on what it's been trained on. All right, stay with me because I'm going to try to use a sci-fi reference to make the point that LLMs still really in need of search to work well. Again, make no mistake, LLMs are a huge advancement in the information retrieval world, but vector databases alone are missing a critical component in the formula for calculating subjective relevance. And nothing does that better than a search engine. This is going to be a very simplified explanation, but a vector database has two steps it performs to find content matches. The first step is to vectorize the incoming query to the same model that the ingested documents were vectorized with. This step essentially turns each of the incoming search terms into a set of coordinates that represent that concept within the vector model space. We can imagine each of those plotted points are like a ball expanding in all directions from the coordinates. The further away from the coordinates that the edge of the ball gets, the less relevant it is to that individual concept. The balls are actually very misshapen because tension is being applied in all the dimensions that the model will allow. But for simplicity's sake, let's pretend they're perfectly spherical and that eventually they overlap each other. Again, this is very simplified, but a vector database uses the relative distances and adjusted scores between all of those different coordinates to find the center of mass or those query terms within the model space. This is the most probable context that the query terms map to within this model. This brings us to the second step of a vector database search. That center of mass coordinate is then used to find the most relevant documents by distance according to their position in the same model's vector space. Even as good as large language models have gotten, and they will continue to get better and better, there's still an important missing coordinate to this formula to calculate the very best relevance. And that originates from outside of that vector space model. It's the coordinates of the user's context, the entry point into the vector space boundary. It's the seventh symbol that lets you travel through the Stargate to your correct destination. With that additional coordinate, you can add additional tensors to modify the query weighting to be closer to the user's context and alter the scoring to select the most probable context in the vector space. But most vector databases don't have the capabilities of a search engine, nor the ability to accept additional input in the form of a context window the way you would using retrieval augmented generation to a generative AI service. This is why Elasticsearch makes for a superior vector database. With Elasticsearch as your vector database, you can vectorize your content using third-party models and then bring to bear your additional context that LLMs don't have any knowledge of, including your own domain-specific content and non-content signals about the data being queried or the user asking the question. I'm going to co-opt the RAG acronym here in quantum new term. I hope it's new. RAVS is Retrieval Augmented Vector Search. The additional context that Elasticsearch can provide can modify your center of mass to be closer to the user's intent or permissions, resulting in a better targeted context for the vector search to pinpoint on. Elastic has the ability to combine multiple search modalities to further refine or expand a vector search. And then hybrid search provides the flexibility to filter, inform, and modify your ranking to generate the absolute best context and results possible using all available information. So now, if we come back and revisit the student-teacher example, we have the additional user's context added to the mix. So this document might come up now in a search query being conducted by the school's HR department, who are trying to investigate reports of a disgruntled teacher, or the same search result might be returned to a guidance counselor who's helping a student through a tough time. The point is that this should be weighted differently depending on who's asking the question. As we've seen, most vector databases are only able to store vector embeddings and then retrieve the closest numerical match to that vector. Some vector databases allow you to also create those embeddings on the content being stored, but really only Elasticsearch has those abilities and all of the standard search capabilities combined. There's additional considerations about how those vector capabilities get integrated and deployed to your system, and that's where Elastic really shines. Elastic has been synonymous with search for nearly 15 years now. Elastic basically makes fast data access from anywhere a product in itself. It's like data as a service. Thanks for your time today. I hope this was helpful and informative.